right, our last topic for this exponentials unit is geometric sequences. A geometric sequence is one that has a common ratio. This common ratio is written as r, and we can find it by taking the second term and dividing it by the first term. And we can do that because we are multiplying or dividing the same number each time to get to the next term in my sequence. There are two ways that we can write this. We can write it in recursive and we can write it in explicit. These two forms were the exact same names when we talked about arithmetic sequences. A recursive formula finds the next term of a sequence by using the previous term. So just like last time, we have some gobbledygook to write down. We'll always write our first term. We need that in a recursive formula. We need that first term. We're still going to write that gobbledygook a sub n equals a sub n minus 1. But now we're going to multiply by our common ratio. So remember, a sub 1 stands for my first term. A sub n is your desired term. You want this term. That's what desire means. N is your term number. What number in my sequence? A sub n minus 1 represents your previous term. And R is your common ratio. Now, when we talk about the explicit formula here in a second, all these pieces that make up my formula are the same in the recursive. So take a moment and copy those over. Okay, now that we've copied those over, so we can save ourselves some time in a minute, let's look at an example of the recursive formula. So, given this sequence, we want to write a recursive formula. So the first thing we're going to write is that template. We want to get rid of all that gobbledygook. Okay? So I need to identify my first term. My first term is the first number that I see in my sequence. It's a 7. Then I need to take my previous term and multiply it by my common ratio. My common ratio, remember, can be found by taking my second term and dividing it by the first. So let's take 21 and divide it by 7. I get 3. I must be multiplying by 3 each time. 21 times 3, that does get me 63. 63 times 3. And this pattern can continue. That's what the recursive formula is doing. It's reoccurring. I have a reoccurrence of multiplying by 3. So I can find my fifth term by taking a sub 4 times 3. I can find my sixth term by taking a sub 5 times 3. You are continuously multiplying by 3 to build your sequence. That's what a recursive formula does. Now the second type of formula is the explicit formula. Now when we talked about arithmetic sequences, I told you to think of explicit when you want something specific. When I'm looking for a specific term, I want to use this explicit function. This explicit function is a sub n. is equal to your first term times r raised to the n minus 1. Okay. Since we have a sub 1 down here, we have to take it away from what we're used to calling our time. Okay, we have to take it away from our sequence. So looking at this equation down here, okay, this example, we have a sub n. We're going to multiply something, and we'll have n minus 1 at the top. So the first thing we want to look for is my first term. That goes in this first spot here. And my common ratio is the same from my recursive formula, so I'm going to put a 3 in here for my base. And I've now written an explicit formula for this sequence. So let's try some examples on our next page. If you flip this page over, I'm going to do the evens as an example. So we want to find the common ratio. Remember, your common ratio is your second term divided by your first. So how many times can 10 go into 100? It's 10 times. Then find the next three terms. So we're going to be using the recursive formula. We're going to say, all right, this is 1, 2, 3. There's 4 terms. So my fifth term is my fourth term times 10. So what is 10,000 times 10? 5 zeros. And then times 10 gets me my sixth term. And then times 10 will get me my seventh term. Put in my commas there so I know what this number is. So in number 4, again, we find our common ratio by taking our second term and dividing it by our first. So how many times can 4 go into a negative 20? You should get a negative 5 times. So that means we're multiplying by a negative 5 to build my sequence. So my fifth term is going to be a negative 500 times a negative 5. I'm going to times this by negative 5. And I'm going to times my sixth term by negative 5 to get my seventh term. So these are the next 3 terms in my sequence. We actually use the recursive formula to do that. We continuously multiplied to find those next terms. Now let's look down at number 6. The first term of a geometric sequence is negative 3. So I'm going to write that as a note. My first term is negative 3. My common ratio is 2, so I know r equals 2. And they want me to find the 8th term. That is something very specific, so we should be using the explicit formula. Remember, the explicit formula is a sub n equals a1 times r raised to the n minus 1. So let's fill in the things that we know. We know we want the 8th term. We know that our first term is negative 3. We know that our common ratio is 2. And we want to put n minus 1, but what spot did this 8 replace? It replaced that n spot. So that means I should replace this n with an 8 as well. So let's type this in our calculator for our final answer. We're going to say -3 times 2 raised to the 8 minus 1. Now what's 8 minus 1? 7. So you could have typed in a 7 as your exponent if you wanted to. So a sub 8, my 8th term, is -384. Okay. So let's look down at number 8. They want to know what the 5th term is. That's something very specific. So remember, we want to use the explicit formula. But let's answer these questions down here first. Okay. The easiest one is to answer is my first term. That's the first thing I see in my sequence. It's a 9. Now what's my common ratio? What am I multiplying by each time? If you're having a hard time determining that, remember your ratio is your second term divided by your first. How many times can 9 go into 27? 3. So now let's use this information to help me find my 5th term. I know my common ratio is 3. I know that my common ratio is 3. So we just put that in the wrong spot, unfortunately. So let's erase that really quickly. My common ratio is 3. My first term goes out front. That one's 9. So there's our equation there. And we're looking for the 5th term. We're looking for a sub 5. So 5 is in this n spot. We're going to replace the 5 up here as well. So let's put it in our calculators again. 9 times 3. We're going to raise it to the 5 minus 1. Enter. And we should get that my 5th term is 729. So let's try this last example here, number 10. It's a word problem, but it's set up the same way. What they've done is they've told me that my years are my terms, my term numbers. Okay. That means how much I make an hour is my term. Okay. Or my sequence. So what they're saying is my first term is $8. My second term is $9.60. My third term is $11.52. So let's fill in these questions here. My common ratio. I need to take my second term, $9.60, and divide it by $8. This is going to be 1.2. So I'm going to put 1.2 in for my common ratio. Remember, your first term is the first thing you see in your sequence or in your table. So this is going to be $8. Now, since they want something specific, we have to use this explicit formula. And we're going to substitute in everything that we know. Once we've substituted in everything that we know, we want to substitute it into our calculators again. And we find that after I work 6 years, I am making $19.91 an hour. So my challenge to you now is to finish the odds on this page and come to class prepared with some questions.